Good morning, everyone, and thank you all for joining us this morning. This is the next installment in our series, Storage for the Software Seller. My name is Doug Schofield. I am the partner technical specialist responsible for storage support for Converge. And we arranged this series to provide some messaging to the sales community at Converge. Uh, Sorry, I'm kind of multitasking here, letting people in the door. Um, so that you can have some idea of how to take messaging that you may or may not already be familiar with, but it's talking about delivering this messaging through sort of a brand new door. If you are a traditional storage infrastructure seller, perhaps that means that we're talking to a new element within our clients that we may or may not have current relationship with. If we are a software seller, chances are a lot of these topics are things that we're already talking to our clients about, but we may or may not be talking about the implications of adding a data element to that solution. Our ability to do that, to take all of the front end conversations, in this case about an AI opportunity, and adding a data element to it might be a competitive differentiator. And so certainly it's something that no matter what your role at Converge is, there's probably something you can take out of this. So now I'm going to get out of the way, introduce our speaker, Mr. Jason Harrell, who is a business development executive in the storage space, if I understand correctly, you've just gotten a new role.
Yeah,
But when we did this, that was the role. And I want to turn it directly over to you and start talking about IBM Storage Scale in the context of a data and AI conversation and opportunity. Jason,
yeah,
take it away.
yeah, absolutely, guys. And we put these charts together a little while ago, and I'm gonna just lead off by saying my apologies. I was out for the last couple of weeks, had some personal stuff going on, and within that time frame, have also switched job roles here. So it's interesting since, like Doug said, since he and I talked last, we've now gone to market with Watson X the Watson X portfolio, as you guys are familiar with it as, right? So Watson X.ai, Watson X.data, Watson X.governance. In addition to that, we have Ceph. In addition to that, we have storage scales. So we're going to try to weave in all those topics and subjects together here. But I think the one thing that I want to lead off with and just impress upon you guys right at the onset is that, from a sales perspective, from a business perspective, we're in the right place at the right time. We're very fortunate to be in storage sales and infrastructure sales at this point because, just like with the cloud, cloud runs on something, right? The cloud is not just some amorphous, entity that's literally in the clouds. You need underlying infrastructure to run cloud applications, and so on and so forth. AI is the same way. And we'll talk about this as we get into the presentation. And the reason why, again, I say that it's very fortuitous for us to be in this space at this time is because AI is just utterly exploding, right? We go back to just 2017 or a few years ago. From a budget perspective, companies, the AI budget was nascent. If you talk to any CIO, CTO, just going back 5 years pre-COVID, no one was talking about AI unless you were already in that space, right? Unless you were already like, Tesla, Elon Musk, you were developing autonomous vehicles, or, to some degree, banks and folks in life sciences, they were, putting a toe in the water, if you will, for that type of advanced technology. But certainly it wasn't as prevalent as when Chat GPT debuted, right? Chat GPT, was the Pandora's box. It exposed the entire world to the power and potential of AI. And so, you think about, since again, going back to 2017, all the way up until now, the adoption, just in terms of corporate adoption for AI, has increased, over two and a half times, right? And just in terms of AI it being part of our modern lexicon, right? You have, folks that can barely power on a PC know about Chat GPT. They understand the concept of AI. So the fact, that it's grown in prevalence and adoption is certainly no understatement. You guys know this, but how do we contextualize this, and also how do we capitalize on this not just bandwagon, because I think AI is here to stay. I don't think it's kind of the new app that's going to stick around for a little bit and then in 5 years we'll be talking about something else. I think this is fundamentally going to transform not only business, but has implications on the broader society as well. And that's kind of what leads us to this slide. We were at one point kind of in a a plus AI world, which meant we'll, especially at a corporate level, we'll look to adopt AI, we'll find a use case for it. We think it can be useful, but we're not really sure exactly where. Fast forward to again post Chat GPT, now everyone is looking to lead with AI. Now the race is on. How can we exploit AI? Where can we leverage the benefits and the efficiencies and the cost savings of AI in our business? So everyone is looking to get in on the race, if you will. And so now AI is not only a technology that is seen as useful in terms of optimization, but it's also driving customer experience. It's creating new lines of revenue for businesses. It's helping them to understand their business better, to eliminate or to mitigate customer attrition. It's helping them adopt customers more quickly, bring new products and services to market. So it is really game changing and changing the landscape of technology as we've all witnessed. And so, when you think about what some of those challenges are, of course, with adopting a technology like AI, first and foremost, there's always been an explosion of data growth. That's nothing new. We've been talking about data growth forever. But I think that the challenge is, especially nowadays with companies ingesting so much data, third-party data, they're trying to take advantage of the organic data within their organization, not to mention data coming in off websites and social media and all types of IoT sensor data. The pace of data growth has just grown exponentially over these last few years, and data is also more federated. It's not just in the data center, it's not just in colo, it's not just in the cloud, but it's everywhere. And that's what makes it difficult, because it's on users' laptops, it's again in the cloud, it's at the edge. It's in our wearables, our smart devices. Data's everywhere, and it's getting collected from everywhere, which makes it more difficult for companies to ingest that data, and not only ingest that data, but to transform that data into actionable insights. And then in terms of formats, and this is more of a Watson X theme, because Watson X really helps deal with this concept of data coming into different formats. That's a real challenge for most data scientists. You have lots of data. Okay, that's actually a good thing for data scientists. But the next thing is, where is the data? And we've got ways in which we can help them find the data using Fusion Discover. And we'll talk about that a little bit too. But then the data comes in different formats. It's not all the same. Some of it's, Word documents, some of it's Excel, some of it's CSV, some of it's this or that. So then you have formatting issues, and, so you have a lot of data, it's everywhere, but then now it's in multiple formats, which becomes a pain in the butt to manage. And then, with all that data, you can also have challenges with data quality, which makes sense, right? Because I got a lot of data, that's awesome, but how relevant is it? How useful is it? To what extent do I need to massage this data in order to make it something that I can actually ingest into my workflow, train my AI models on it, run my business analytics on it, and actually derive useful insights. So these are just some of the challenges with not only, again, adopting AI, but then trying to corral and manage the data that helps drive the AI that we're looking to adopt. Now, before I really
Jason,
launch, I'm sorry, go
just
ahead.
just very quickly, I should have mentioned right up front, if there are any questions during the course of this, please enter your questions in the chat, and I will be monitoring that and feeding that information to Jason as he goes along here. So please do not be shy. If you've got any sort of questions, let us know. Jason, go ahead.
Absolutely. Yeah, and thanks for that, Doug. Yeah, 'cause sometimes I can get going, guys, and I apologize. Feel free to interrupt me anytime. But again, before we launch into this, I want to make this distinction because this is very relevant, very important. Now, AI comes in different flavors. Let's just maybe, or say it that way. And in my mind, there's enterprise AI, which is very akin to business analytics, or for example, companies in the past would have these large data warehouses. They would ingest all this data. They would bring it into this data warehouse from multiple databases inside the company. They would perform ETL operations. They would transform that data, and they would produce reports. They would drive business intelligence dashboards. They would run all sorts of queries in order to understand same store sales, trends in the business, or just try to identify patterns in their data. And that's a very traditional, common use case. A lot of our existing customers, they have data warehouse solutions, whether it's from us, IBM, or from Oracle, or something else, SAP. A lot of our large clients have data warehouse solutions today. And that tends to be more enterprise AI, which is then applying the potential and the power of AI to that structured data in order for me to do things like enhance customer service, build chat bots, or leverage some of that data in order to optimize document analysis. Because take document intensive industries like life sciences or healthcare or even financial services, where I'm dealing with thousands or hundreds of thousands or millions of contracts, right? How can I begin to quickly analyze those documents and look for keywords in order to optimize the amount of work that claims adjudicators or for example, loan officers need to view when they're trying to determine whether or not an application is approved. There are technologies or AI technologies that businesses can leverage to help optimize those workflows. And those tend to operate on traditional structured data. Now, that's enterprise AI. When it comes to GPU accelerated AI, which is where you tend to lean a little bit more towards the scientific type workloads or the very technical compute workloads, that's where you're looking at, again, going back to the Tesla comment about Elon Musk, autonomous driving type workloads, image classification, where companies are, leveraging, for example, camera data from their factory floors, and they're looking for defects in parts, or they're doing health and safety analysis to make sure that workers are wearing their helmets and their safety vests and safety gloves and so on and so forth. Any type of AI that processes images or processes video, which, as you see from those use cases in the bottom right corner of your screen, those are the type of use cases that process images and video and audio. That tends to be more GPU accelerated AI. And the reason why this is important is because when it comes to storage scale and when it comes to Watson X, and sometimes the ability to sell both or position both, this is where, there's gotta be some nuance to the conversation, right? So Watson X is a great technology, and it will solve a lot of traditional business AI use cases or enterprise AI use cases. In this initial release and subsequent releases, we are planning to add storage scale so that it can handle even more use cases outside of some of the traditional business AI use cases. But when we're looking at more of the technical compute use cases, like in high frequency trading, life sciences, drug discovery, computational fluid dynamics, use cases that are just very CPU intense, thousands of compute clusters, performing thousands of jobs across those compute clusters. When we're looking at those kind of deep intensive workloads, we're looking at more of a technology like storage scale. So I just wanted to kind of make that distinction at the beginning. So you guys won't think it's necessarily a one size fits all. There are cases where, Watson X data is going to make sense. There's cases where storage scale is going to make sense. And then there's going to be future use cases where both of these can be fused together to create a holistic storage solution, depending on what the customer requirements are. So, with all that being said, there's no shortage of opportunity. Again, going back to that theme, we're seeing a compounded annual growth rate in terms of scale business in double digits, which is awesome. And just as an industry, I just saw a report from Hyperion this morning that indicated that, companies' AI budgets, which again, going back just pre-COVID a few years ago, were non-existent. Now every major company has an AI budget or has an AI line item on their budget, because AI is that technology where every company has to develop a strategy. They have to figure out what it means to them, how can they capitalize on it, and how can they extract the benefits from it. And again, when it comes to managing data, it's very challenging. Organizations still today, with all the tools and technologies available, are still struggling to analyze their enterprise data. A lot of time is still spent on data wrangling, on identifying relevant data, and optimizing that data. for analytics and for model training. And also data silos continue to be an issue because a lot of large organizations that have grown through M&A, mergers and acquisitions, they have different IT systems or different ERP systems or different data warehouse systems and so on and so forth that they're trying to now fuse together. And it creates a challenge for data scientists and for AI researchers who are trying to access this data across different either application silos or even physical silos, in the sense that the data might be co-located in a different country if it's an international company, and there could be GDPR issues, so on and so forth. So there are some real challenges that we have to help our clients overcome. And that's why we tell our clients that there is no AI without IA. You have to have an information architecture that can help you accelerate the time to value and the time to market and the benefit that ultimately AI is going to bring to your organization. So I kind of skipped past the client pain points because I think we've already talked through enough of those, and I'm trying to be respectful of time. So storage scale is the right solution when it comes to, again, those technical compute, those very high performance workloads. Storage scale is a purpose-built high performance network cluster parallel file system. I know it's a mouthful, that provides unified object access, a unified file and object access across a global namespace. And we'll get into what that looks like. But the reason why this is important is because the data center has changed dramatically. Not only are, a lot of data centers adopting AI, but the storage requirements for AI are fundamentally different than the storage requirements for traditional databases or traditional, applications, data center applications. And so when you have a use case like AI that has a fundamentally different IO profile in terms of how it needs to access disk and the type of throughput that it needs from disk, traditional disks really just can't keep up with the requirements for feeding those data hungry GPUs that are often used to train and build those AI models. And that's ultimately why storage scale is growing by leaps and bounds, especially these days as clients are looking to adopt AI even more so. So what is storage scale under the covers? Again, it's a unified file and object parallel file system. But what does that mean? It means that you can handle multiple workloads. You can handle traditional HPC workloads. You can handle newer next generation workloads that are both on-prem and off-prem, virtual machines, bare metal, or containers. Scale can support container native. It could support container native applications. It could run in a container native environment. You can support traditional BI and analytic applications, as well as you could do, bread and butter use cases like backup and archive. It supports multiple protocols, which makes it the Swiss Army knife. There's multiple way ins, there's multiple ways in, there's multiple ways out. Storage scale can accommodate, again, applications that need to write data or read data over CIFS and NFS, object, POSIX, or HDFS. Regardless of the storage protocol, for the most part, we can accommodate. And then when it comes to providing the federated access to data, which means that I can have my researchers, my data scientist team, located over different geographical locations. They can be in different states, cities, countries, doesn't matter. I can provide data caching service to make the data that they need to access look local or appear local to their geography. So instead of incurring the latency of going across the WAN every time you need to read data or write data, I can provide data caching service, which accelerates that throughput, that access to data, which helps them to be more productive, as well as I can facilitate data sharing, which is often a very painful issue in a lot of large organizations. Some of these data sets that data scientists are training models on are really large. And when they have to copy those around, that adds time, latency, and that's time that they can be actually working, being productive, as opposed to waiting on some data set to transfer. So that's key. But then also the economics, the storage economics that come with storage scale. As many of you guys know, we support tiering. A lot of our competitors, like for example, Vast, they like to say, well, no more tiers, right? And they tongue in cheek and they think it's funny. Well, our clients don't think it's funny because even though we're coming out with an all flash model, so to speak, with the 6000, and we'll continue to innovate on the ESS platform. The fact of the matter is that there is no cost economics that are more that are better than physical tape. And the fact that you have clients out there with very large data sets, and those data sets have very varied life cycles in the sense that some data sets they may be relevant for a month, some data sets may be relevant for a week, some may be relevant for several months, but regardless, we can manage the disposition of data based on its access, based on how frequently it's accessed with storage scale. So we can move from a high performance NVMe tier to spinning disk to object or physical tape. And then if we go to physical tape, not only do we tier that off to the cheapest storage there is at this point, but then we also create a physical air gap copy of that data, which means that if there's a ransomware attack, the ransomware cannot affect the data that's on physical tape. So you kind of get a 2-for-1 there. In addition to that, we can also deploy scale on all the major public cloud providers, in addition to on-premise bare metal, virtual machines, so on and so forth. So scale is that multi-site, multi-tier, multi-protocol, multi-workload workhorse of a file system that again was designed from the ground up to support initially high performance compute workloads. But nowadays, because the IO profile is so similar, it supports those GPU accelerated workloads like AI, machine learning. So why not traditional storage? And I mentioned this before. Now, this is not so much as vast here, but this is, let's just take, for example, NetApp. So a lot of clients, when they go to integrate AI into their business, they'll use existing storage. They'll use what's on the floor because it's already there and they figure it should be good enough. And when you're just doing pilot projects or trying to develop MVPs, minimally viable programs, typically the storage on the floor is good enough because you're not throwing 8, 12, 24, 50, whatever GPUs at it. You may have a workstation or a laptop with an NVIDIA GPU inside. And that's more than enough. And NetApp or any type of NAS filer can easily support, a handful of GPUs, a couple, 2 or 3 GPUs. So, that's usually how we get started. The problem is though, is that, they don't scale as effectively as we do. So when it comes to clients that are managing multiple petabytes of data, it's more difficult for our competitors to scale as we can, especially being able to maintain not only a global namespace, which is more than just a mount point, but then have parallel access to the data so that each storage node, if you will, can supply data to the requesting client. So as we'll get to in the next few charts, what you'll see is that what NetApp does, and it's great that they can federate across multiple filers, but you create hotspots because the files are not peanut butter spread, let's say, across all the filers. They're stored individually or on separate filers. So depending on what file I'm accessing or, at any given time and how frequently or how intensely I'm accessing that file, I can create a hotspot on a given filer because I haven't federated or sharded or erasure coded that file across all the filers in my cluster. And that's one of the biggest challenges is that NetApp doesn't effectively do that. And so what you end up with is you end up with hotspots and you end up with issues with respect to scaling from a throughput perspective because you're also limited to Ethernet, which is, again, great protocol for starting off and for certain use cases. But when you really get into these computationally intense use cases, it's all InfiniBand. When you think about what NVIDIA is talking about, when they go to market, when they, share all these press releases where they're, selling these NVIDIA DGX super pods and these large scale clusters, the primary data fabric is InfiniBand. And that's something that Storage Scale has been supported for a very long time. And again, with Storage Scale, you can have a global namespace across multiple storage nodes, and you can write that data across multiple storage nodes. And then also, again, because we are global, we can support multiple remote sites. And so that's, again, what makes us uniquely different, is that we have the data caching capability. We even have data virtualization capability, which means that if there is a NetApp filer on the floor and there is relevant data in there that the client needs to access, but they want to leverage the throughput of Scale, we can leverage AFM caching and set up an AFM cache in front of that third party, that non-IBM, that NetApp storage, where we can ingress that storage from NetApp into Scale and make that data available for analytics or for machine learning, AI model training. So lots of capabilities and flexibility with respect to Storage Scale. and I mentioned this before, and this is a animation slide, but this is again the power of storage scale is that I am spreading my data blocks across multiple storage disks, across multiple storage nodes. So when I go to read or write my data, I'm taking full advantage of the entire bandwidth and all of the backend infrastructure to read and write my data. I'm not just hitting one particular storage node or one LUN or one volume, which again can create a hotspot, it can create a performance bottleneck depending on the operation. But I am able to read and write, in a parallel fashion to all of my backend infrastructure over Ethernet or InfiniBand, which again is why Scale is a superior file system. So I'm not going to get into this. I've already kind of talked about this already. This really just speaks to positioning storage scale. And like I mentioned before, GPU accelerated workloads, multi-site, multi-cloud, remote access and collaboration, real-time analytics, genomics, microscopy, all of those type of, data intensive, computationally intensive workloads. And of course, any customer requirement that has to do with data lifecycle management. So if the customer, wants to tier off data to the cloud, they want to tier off data to tape, then Storage Scale can do that and provide those storage economics. So, just really quick, and just a bragging slide, right? But for those of you who don't know, Storage Scale has, it's interesting, there's a lot of urban legends out there. Oh, Storage Scale is this, Storage Scale is that. It used to be GPFS, and it's been out there for a long time, and we're proud of the fact that it's been out there for a long time because there's not very many technologies that have been out there for 25 years, like Storage Scale has been, formerly GPFS, that is still relevant in mainstream modern business today. And that's evidenced by over 3,000 clients. 9 out of the top 10 automakers and investment banks use Storage Scale. We've had a number of accolades over the years. We don't talk about this as much as we should, but Storage Scale is definitely a very venerable and still relevant file system. And that's evidence again in the Gartner Magic Quadrant. So we look at the upper right in the leadership quadrant, there's IBM. And again, this is just more evidence to say that clients continue, year after year to vote with their wallets, and they continue to renew their S&S, their maintenance, their software maintenance and hardware maintenance on Storage Scale and ESS respectively. And they continue to invest in the platform and buy additional growth and do, asset refreshes and so on and so forth. And, we're also seeing an uptick in new logos, which not just existing customers that we're seeing that revenue from, but we're also seeing a ton of new logos that are now adopting Storage Scale because they're in a situation where they need to adopt AI, and they needed technology that was purpose built to enable them to do so. These are some of the use cases for Storage Scale. Some of you may or may not have clients that are further down the road in their AI journey, right? Because I look at AI as a journey. It's a process. No one gets there overnight. It usually starts off with a handful of data scientists working on identifying key use cases within the company. And then as they begin to solve key problems within the company, the investment in AI grows, the infrastructure grows, the team grows. And then in big corporations, what you'll often see is AI Center of Excellence, which is a cross-functional team of business leaders as well as data scientists and other data engineers and just data savvy folks that come together to, again, from a cross-functional perspective, identify areas in the business that can better benefit from AI. But regardless of where the company is in their journey or their maturity of AI, there are a lot of different use cases for Scale that don't necessarily involve AI, which is where I'm going. So, you can leverage Scale, for example, for backup and recovery. There are a lot of clients that still are challenged with doing high-speed backups to meet their backup windows. Storage Scale or ESS can be a great target for just ingesting data at a high speed. You have other situations where clients are using Cloudera or they're using Hadoop and they need to accelerate their data queries, or the infrastructure that they're running it on has become long in the tooth, or because they have grown over time, they have so many different Hadoop and Cloudera clusters that it becomes difficult to manage, as well as the hardware associated with those and the refresh that hardware. It just becomes a bigger pain in the butt. The more clusters you have, the more hardware you deal with. So they want to collapse some of that hardware. Storage Scale can be a great fit for clients that are looking to collapse the storage associated with those clusters, because a lot of those Hadoop and Cloudera clusters or use storage-rich servers. So there's storage and compute that's deployed as that cluster grows. What Scale can allow you to do is eliminate that storage within the client, move all that down in the storage scale, and then you can reduce the amount of compute nodes that are required. And then, of course, you get the performance benefits of leveraging storage scale. So again, that's another use case. Again, for clients that are using Hadoop or Cloudera, storage scale can be a great use case to consolidate, those clusters, those applications, and to help them optimize their costs. So it's not all AI, but certainly, AI is a big component of what our clients are doing today. And so we have to make the case for storage scale for that particular use case, because it obviously is so big, and it's on the forefront of our client's mind. So different deployment methods. I think I've already mentioned this. You can deploy in the cloud, you can deploy on premise, and you can deploy via a hardware integrated solution, which is the ESS, the Elastic Storage System platform. So lots of flexibility here. We don't talk enough about our ability to deploy in the cloud, but for those of you who have customers that are using AWS, for example, we have a cloud kit. And that cloud kit enables clients to deploy a Scale cluster inside of 15 minutes, believe it or not. So it's orchestrated by Ansible. It leverages Terraform and some other scripting languages or tools to automate and optimize the deployment of storage scale in AWS. But it dramatically simplifies provisioning and deployment of storage scale in AWS. And we're going to take that cloud kit goodness for AWS, and in the subsequent releases, we're going to use that. We're going to leverage that in Azure, and we're also going to leverage that in GCP. So in the not too distant future, we will have that same capability across all three public clouds. Although, obviously there are people who have developed their own solutions to sell that as a service. But if you're looking for supported IBM deployment option to accelerate, your ability to get scale up and running in the cloud, we are working on supporting Azure and GCP with CloudKit as we do today with AWS. So please, if your clients are going to the cloud, they can take Scale with them, especially if they have Scale on premise. That will be great, because then they don't have to learn a new tool. They can just continue their investment in the storage scale technology. If they don't know what they're going to do for data and AI in the cloud, storage scale, again, is a great technology for the cloud, because it takes those same capabilities on premise with the multi-protocols and the parallel storage and all that stuff, and allows you to deploy that in the cloud to take advantage of the same benefits in terms of performance and data resiliency and tiering and all that good stuff. So, I kind of skipped ahead on that one. Storage scale licensing. A lot of clients want to know, like, what should I do? What should I start off with? We get questions from reps. My clients looking at storage scale. How should I license? Should I go with DAE, Data Access Edition, or DME, Data Management Edition? I'll tell you this. When you look at the chart here, as you can see to the left, those are the features, and then to the top, those are the different license editions of storage scale. Use this as a rubric. Use this as a guide to help you license. As you can see towards the bottom, or the first few lines rather, there's really no difference between Data Access Edition or Data Management Edition. A lot of these capabilities are the same, but once you get down to the bottom in terms of needing asynchronous DR with AFM, that's more of an advanced feature. File audit logging, it's more of an advanced feature, as well as encryption, which I don't see on here. I must have used a different slide, but encryption should be on here as well. You cannot get data encryption in Data Access Edition of Storage Scale. You can only get encryption in Data Management Edition and Storage Scale. So if a client needs data at rest encryption, they must upgrade or purchase Data Management Edition. And then for clients that are looking to deploy storage scale on their own x86 hardware, we have Erasure Code Edition, which allows storage scales to take advantage, which allows clients rather to take advantage of their own x86 hardware, which could be good for smaller clients that are looking to build a smaller cluster, or possibly potentially for edge locations, and even in the cloud. We see a lot of clients that are deploying storage scale in the cloud leveraging Erasure Code Edition. So again, reference this chart if you need to know, and I'll update it when I post the charts so that you'll know what are some of the key capabilities within the editions and when you should when you should quote what.
Jason hates Doug. You've mentioned now AFM. I'm wondering if you could spend just a minute or two talking about exactly what AFM is and why it's relevant to this whole conversation, because acronyms sometimes don't, they get lost unless you already know what they mean.
Yeah, absolutely. So AFM, Active File Manager, I'm sorry. So Active File Manager, we now refer to it as data caching services, but basically when Active File Manager was developed, it was developed to help scientists share data across geographically dispersed locations. So if I'm in and if I'm in Tulsa and the cluster, the let's just say the cluster that I need to work on is in Tennessee. Um, all right, that's great. I could FTP the data over. I could, maybe use Aspera, but I need to have a local cache copy of the data so that I can work on it as if it were local and then be able to automatically push those changes back into the home cluster in Tennessee. So AFM, Active File Management, gives me that ability to do read-only data sharing where maybe I'm just distributing data from the main location to separate locations. It allows me read-write access. So if I have edge locations and I need to have read-write access to the cache, data cache, I can leverage AFM and that mode. And then also I can leverage AFM again for data virtualization, which means that if I have non-IBM storage on premise, so I have a NetApp filer, I have an EMC Isilon filer, or I have an S3 bucket in AWS, and I want to integrate that data into Scale, or at least I want to make it accessible via Scale, I can leverage AFM to create somewhat of a virtualization layer for that non-IBM storage that I can now funnel into my AI workflow and leverage that data via Storage Scale. So then I don't have to, you know, go over. I don't, I don't have to independently access those data targets, those data sources. I can just continue to access all my data through Storage Scale. So that's kind of an oversimplified way to explain it, but that's kind of what the technology does, if that makes sense.
Jason, thanks so much. Yeah, that's an absolutely vital element to this AI story, because one of the chief challenges that your customers will be facing is that I've got data in so many different locations that is relevant to the AI project that I'm trying to build, and the headaches associated with having to move data or replicate data to alternate locations can a lot of times be very daunting. In fact, they can be project killing, whereas the AFM capability allows them to virtually cache things, pull it into a common location, do what you've got to do with it, and then the originating data locations still maintain ownership of that data. Jason, thanks for taking a minute on that.
Oh no worries. Let me see here. So so from a use case perspective, I've got a few things. So this is kind of an autonomous driving use case, and we actually did this with Continental Automotive. So they needed to accelerate their model training times for AI. They as a company, well, they've got a number of different lines of business, but one of the things that they do is they actually build and train AI models for companies that are looking to accelerate their roadmap into autonomous driving. So obviously Tesla, they're doing their own thing. You guys may have recently heard their announcement where they're building they've already purchased, thousands of NVIDIA GPUs, and they're building out what will, and I think they'd say by 2025, it'll be like the second fastest supercomputer in the world. But for a lot of companies that don't have the deep pockets of Tesla, automakers that don't have the deep pockets of Tesla, they leverage third-party companies like Continental to do a lot of the ECE, the engine control module development, and some of the other electronic component development that goes into autonomous driving. And a lot of that is algorithmic. And so anyway, Continental Automotive, they needed to accelerate that ability because they needed to enhance their time to market. They needed to get models built and trained faster. They needed to more quickly iterate and capitalize on new capabilities, new innovations. And so they came to us with a need to accelerate their workflow, to accelerate their pipeline. And so we were able to help them achieve a 70% increase or decrease in model training times, which is huge. That means that they could train more models faster, as opposed to what they were, which again accelerates their time to value, their time to insight. And then also we were with that able to allow them to do again more work. And so that's really the key with a lot of these large data and AI shops, a lot of these companies that have really embraced and and have infused their organization with AI. One of the keys is that for them is they want to do more experimentation, because a lot of this is science, but a good deal of it's kind of art, so to speak, in the sense that it's a lot of trial and error. There's a lot of fail fast. And so when you're in that kind of space where it's okay to fail, but you need to fail fast and fail often, so to speak, you need that ability to experiment. You need that ability to iterate, fast, and that's what speed gives them. It gives them the ability to try new things, fail fast, and continue iterating until they can develop a working prototype. As opposed to, let's say, they go to train a model, that model takes 3 weeks to train. They got to wait those 3 weeks to see if that model is even going to work. As opposed to if we can reduce that 3 week down, those 3 weeks down to 5 days, let's say, then now instead of waiting 3 weeks, they're only waiting 5 days or 4 days or whatever, right? So now they can experiment more, they can do more. And this was a great use case for us because it showed the material impact of having the right infrastructure architecture, right? It's one thing to have storage, but it's another thing to have the right storage, and the right storage can accelerate your AI roadmap. And so this is again a Hadoop use case that I mentioned earlier. There's a lot of Hadoop out there. A lot of your clients are running Hadoop clusters. They're running different versions of Hadoop. They have a number of different clusters for different reasons. Some of them, again, they came through acquisitions. Some were just, as a result of how they budget. Different departments have different budgets, and they may have purchased their own Hadoop infrastructure. But the point is that Hadoop is a very large use case, and this is an example of one. We have another large automotive company that has a really large Hadoop cluster, and they came to us with the need to build a active cluster environment, because their Hadoop cluster, one of the things that it supports is it supports telemetry data capture. So all the vehicles on the road, they capture telematic data, and they send that data over 4G or 5G to this automotive data, to this automaker's facility. And this data is captured in an Hadoop cluster where additional analytics are run on that data. So they needed not only capacity and performance to ingest and manage all that data, but then because it is mission critical, they needed resiliency, they needed availability. And so with Storage Scale, we were able to build an active Hadoop cluster using AFMDR. So using AFM, we were able to build an active cluster that allowed them to have that failover failback capability. So I'll skip that. These are just some other use cases. This one is a good use case. This is a retail company. Many of you have heard of Kroger, shopped at Kroger, seen Kroger. Kroger, they came to us, or rather, they were looking to build a digital twin, or build digital twins of their stores. In addition to that, they were looking to leverage video analytic capabilities within their stores, because they wanted to be able to assess traffic flow. They wanted to see, how people move through their stores. And they also, obviously, from a loss prevention perspective, they wanted to have the analytics in place to be able to detect, potential and thwart potential loss prevention. But the key use case was digital twin, because a lot of times in retail, store layout is huge. Stores, as you know, retail, particularly grocers, there's very thin margins, often single digits, low single digits. So their ability to place the right product in the right location and turn over inventory is crucial. So with building digital twins, they can play around with different store layouts, and they can even play around with different designs for the store, because that, in some cases, just the look of the store could increase sales by 5% or 10%, just depending on how modern or how how the store is laid out, right? So having a digital twin gives them the ability to play with this, to kind of mess around with this before they actually build something, build a prototype store, and incur the costs associated with that. So they needed high performance storage, and we were able to provide a solution to support their NVIDIA DGX boxes. I think they purchased like 8 of them. So inside each DGX is 8 GPUs. So that's about 64 GPUs. Not massive, but certainly pretty large. And again, from a storage perspective, to feed 64 GPUs, that is no small feat, because those things are enormously data hungry. And so that's again why you need something like Storage Scale, because it provides that throughput, that ability to be able to feed those massive GPUs to accelerate that time to value when it comes to AI. So I'll stop there. Any questions or comments at this point? I know I said a lot, so I'll stop there. Any questions or comments?
And certainly feel free to come off of mute if you have a question or an observation about this whole messaging. I think Jason did a great job of talking not just about scale in its own lane, but how it also relates to the other key elements of IBM's storage positioning these days. When we start talking about, the stuff we did at the beginning of the year, creating these 3 focus areas. We've got data and AI, which is right smack in this in the scales kitchen. The whole conversation about unstructured data, but also talking about hybrid cloud and fusion, which we did a session on a couple weeks ago, and the data resilience piece. And in every element of all 3 pieces, scale has a role. And the nice thing is that a lot of you already have some good experience telling this story, and now it's a challenge and an opportunity for some of you to start telling this story to different elements of your clients, and then some others of you who are already having those conversations, the data and AI conversations with your clients, to add this whole story about exactly how we can ensure that when they try to take this thing out of pilot and into production, and all of a sudden the requirements, the performance goes up, exponentially, that we've got a solution that's going to make you successful down the road. And as Jason said, it's not a one size fits all conversation, but when we identify those opportunities that we can look down the train tracks and say, you know what, this two things can happen. You can fail, which would be bad, or you can succeed, which can be equally bad if you're not instrumented for success. So that's kind of where we're going here. And certainly the wonderful thing is that there's lots and lots of experience within Converge. So if you feel like you've got a conversation like this brewing, let's call on the internal resources that Converge with the storage team. Also, IBM stands ready to help anytime you need some help on this conversation to flesh out whether or not it's a viable opportunity for the data element of your AI project. But any other questions or observations here?
And Doug, and while they're thinking, I just want to bring this chart up, guys. I meant to take care of this before today, but it's been busy with the new job change. But so one of the things we've done with clients, and this quote unquote whiteboard can be drawn a lot of different ways. But just to give you guys an example of sometimes what we don't talk about, we need to talk about more, which is better together and how some of these technologies can come together. So we talked a lot about scale. That's all, and we mentioned watsonx, and I've got a couple charts there. But I kind of wanted to show you guys this really quick. So Doug brought up AFM, right? Active File Manager. So in this particular scenario, as you can see, let's say here we've got storage scale. This is our performance tier. So if we've got applications up here that need high performance access to storage all day long, storage scale is the platform for that. Now, at the same time, our clients have a ton of NAS, right? They've got NAS, they've had NAS forever, and they're going to continue to leverage NAS. No problem. Guess what? With AFM, I can connect to that NAS storage, and I can access relevant data on that NAS that may need to be ingested in the storage scale to support those high performance applications, those AI, ML, type workloads. In addition to that, what I could do is I could also leverage Comprise, which can help me to identify stale data, or I can leverage Storage Fusion, or not Storage Fusion, but Fusion Discover, which can help me identify stale data, and I can begin to move some of that data to Ceph or to COS. So then now I'm creating a couple of things here. So for one client, I'm talking about data and AI, but I'm also there addressing their existing pain point on NAS, which is these things keep growing, right? They don't they don't stop growing. And so it becomes an OpEx challenge at some point, and then the maintenance associated with it. And then sellers, it's great. We'll take the money all day long. We'll renew, we refresh. That's fine. But some clients are going to get smart and say, you know what? This is becoming more trouble than it's worth. I need to optimize my spend here. So how do I do that? I can begin to move some of that data down to cheaper storage. So this whole thing about no more tiers doesn't make any sense, because that's not what enterprises do. So I can move some of that data down to cheaper storage. In addition, I can also ingest data directly into this cheaper storage. I may have applications that need to write logs or whatever sort of data to this cheaper storage. I could do that, and then I can leverage AFM to ingress that storage to storage scale again and make it available to high performance applications like data and AI or high performance analytics. So the point I'm trying to show with this chart is that you can actually build solutions that are relevant and very helpful to clients in terms of driving down costs, accelerating, again, I hate to overuse it, but their time to value, which is getting access to the right data at the right time, at the right performance level, as well as, again, this down here could be tape integrating some form of cyber resiliency, because in addition to having it on a lower tier, I can also have it in an air gap facility. So again, this is just kind of the art of the possible, and we can whiteboard this thing 6 different ways from Sunday, but this is the kind of stuff you can do when you harness the power of the IBM storage portfolio. It's not always, either I'm selling this or I'm selling this or I'm selling that. It's I'm trying to solve a problem for my client. My client has XYZ problems, and here's where those relevant technologies can help them solve those problems. And then here's how they work together to do so.
Right. And I think another really important point that Jason's been making throughout is we all as sellers run into the good enough argument. In other words, what I've got is good enough for what I'm trying to do here. But when you talk about AI, in many cases, and especially in this sort of, frontier time that we're in as far as AI, there are many, many competitors trying to do the same things at the same time. And if they can get through 3 iterations of their trial and error on their building of models and that sort of thing, in the same time that you can only get through 1, then good enough is not good enough, because it's gonna make that company look like they're standing still by comparison. So this conversation about not just can you do it, but how fast can you do it in a very, very competitive world is a very viable conversation to bring forward to clients.
Exactly. And then again, I've hit on this a lot, and I have to because it's relevant. This whole, this this tiered approach, the tiered approach is here to stay. If that's the case, AWS should just throw out Glacier, which has been by far, if you look at their revenue and how much they derive from Glacier, it's insane. So if that's the case, Amazon's got it wrong. Azure, everybody's got it wrong, right? We don't tier anymore. Everything's on EBS block volumes, right? Everything's on Flash, and we just go nuts, right? And forget about these other storage entities or storage technologies out there. That doesn't make any sense. What makes sense is the right data at the right tier at the right time. And this is what our clients continue to do, whether they do it in AWS, independent of IBM, or using some other provider or some other technology. This is what our clients do. And Storage Scale enables them to do this beautifully, particularly with large data sets where you don't want all your large data on Flash, because you want to optimize that performance for newer incoming data sets. And yes, we can sell you more Flash and we can grow this thing, but that's not the most economical thing to do. And you're going to realize that, and you're going to realize that we're not necessarily trying to be your storage partner. And you're going to find a solution that more aligns with what you're trying to accomplish. So, we want to be a trusted storage advisor. We want to be in this thing for the long term. And so we want to help our clients extract the most value that they can from their investment.
True. And so think about this now as you go forward, kind of give some thought to the clients you're working with, where some of this story might play. Keep in mind, and Mike Adams added a comment early on saying that Converge is the leader in North America from a partner perspective in selling scale. That's the truth. And what that means is Converge is better positioned than pretty much any partner out there to tell this story. So let's take advantage of that. Let's keep that leadership position. And let's see if we can identify a few real world opportunities where we can apply this information and bring some of these data and AI deals home with a combination of the best front end stuff to actually do uh, the processing of models, but also having the right data solution on the back end. That's all we've got for today, and we thank you all for coming in and joining us today. Watch for the next session, which I think is in early October. Same sort of treatment, and the topic will be IBM Storage Ceph. Thanks a lot, and have a great day.